Hey folks, this is Shetz, and these are the type of problems we're going to do today. Tell me, what does this look like? Well, it looks like a donut. Looks like a Dunkin' Donut. And also it could look like a spare tire. So we're going to be doing area of the shaded figure. And basically what this is it's the big complete circle. And we got to take away this small one, because it's got a hole in the middle. So it's the big circle minus a small one, and that's going to leave us the shaded area. So they're the type of problems we're going to be seeing on slide 3. So if I just put some numbers here. So the small circle, the white circle, has a radius of 2. And then the maroon colored, brick colored circle has a radius of 5. So here's my circle formula, pi r squared. And I have to square the 5. And here's my small circle. It's only got a radius of 2, and we got to square that. Pi r squared is the area of a circle. Well, when I do that, I get 25 pi minus 4 pi. That's going to give us 21 pi centimeters squared. And remember, area is in square units. So this is what I mean by a typical donut problem. Now, if I look at this example, it doesn't look like a donut, but it's a square. Take away the inside circle. So that's essentially what we would have to do. Okay. And again, I still call this a donut problem because it's got the shaded parts. The square, take away the inside circle. I'll do problem 1 with you on slide 3. And we have to find the shaded area. Well, this happens to be a big square minus a circle. Well, a square is 80 by 80, side times side, and then here's my circle formula, pi r squared. Now remember, if this whole piece is 80, then that means the radius would be half of that, 40. So that's why I have the 40 right here. Okay, when we do that, 80 times 80 is 6,400, and then 40 squared is, 4 squared is 16, but then it's 2 more zeros. 40 squared is 1,600, and I put the pi next to it, after it. Okay, when you put this in your calculator, you will get 1373.45 units squared. Now, there is no units to this problem, so I just put units squared. What I'd like you to do is this problem 8 and also problem 9. Now let's talk about this. This is a big rectangle, and then you're going to have to take away the circle and also take away this triangle. Now there's many different ways to do this problem. It's up to you, but I know the radius of this circle, just like the problem above. Here's the whole circle, and that means half of it, it would be 20. And for our triangle here, you have the base. You could do base times height, 1/2. You could do base this way and the height of that way. So just remember, it's the big rectangle minus the circle and also minus the triangle. Please make sure you use the right formulas. And this guy here, this is a circle minus the square. And I'll give you a little hint on this. The radius of this circle, even though this diameter is 16, we know that the radius is 8. Half of it. So that's for the circle. Now, let me get rid of this. And this is a square. Therefore, the hypotenuse is 16. When you go to the leg, you divide by √2 and rationalize. And guess what the square's side is? 8√2. And this side is also 8√2. So make sure that when you take away the square, you have 8√2 times 8√2. Because a square's area is side times side. So 8 times 8 is 64. √2 times √2 is just a 2. So we have 64 times 2. That's what we're taking away from this circle. So please do 8 and 9 on slide 3. Thanks, folks. Take care.